Welcome back to Outward Home Learning. The subject that you're looking at today is computer science and the topic is characters. So first off, we'll go over to Mr. Holton, who'll explain a bit about how characters work, and then you'll have a task followed by exam questions. Both of those will be reviewed by Mr. Barnes. Over to Mr. Holton.
Once you get your head around the idea that everything in a computer has to be in binary, so everything has got to be a sequence of zeros and ones, you might start thinking, well, how does a computer do letters then? And the first solution we had is where we came up with the idea that a particular sequence of zeros and ones could equal a letter. So for example, the one there could equal the capital letter A. And then if we look at the binary for that, one more than that in binary could be the letter B, and so on and so on. And this is called a character set, and it's all the characters or the letters and numbers that a computer can understand. That's what a character set is. And our original character set that was widely used and was very popular was called ASCII, and here it is on the right hand side. And it was fine for our first implementation of converting binary to characters. It had 7 bits available for each character, which meant that we had 128 different characters that we could choose from. And that came with a particular problem, because once you've done all the capital letters and all the lowercase letters for our alphabets, all the numbers, and we do some important punctuation, like things like exclamation marks and hashtags, actually we don't have a lot of space left. So that was fine for our first implementation, but what about, for example, like ASCII had a $sign, but it didn't have a pound sign, and it didn't have things like this letter here, which is used quite a lot in French, and what about the O with the umlaut above it as well, which is used in German, didn't have that either. And so the next solution was to use something called extended ASCII, and that had 8 bits available to it. It had a few more characters in, which catered for sort of Western languages like French and German and languages like that. But again, it didn't quite solve all our problems. Extended ASCII had 8 bits in it, so that meant it had 256 characters to play with. But then, what about this? What about this language here? What about Chinese? If you went to China and you picked up a newspaper, it could have up to about 2,000-3,000 characters in it that you'd be expected to read. So we can't fit that in 256 characters, can we? And what about other languages as well? Because the world's bigger than that. What about Arabic? What about the alphabet that they use? And so a bigger, much more well thought out solution was needed, and that was called Unicode. And that's something that's used mostly in websites today, is this Unicode. Now every character in Unicode can actually be between 1 and 4 bytes. I mean, technically it can be larger than that, but that's the most common implementation. And it actually gives us access to billions of different characters, which is more than we think we'll ever need, which let us do quite frivolous things. So for example, we've got a whole set of characters now, a whole character set dedicated to these things here. Emojis, so you can thank Unicode for the spread of the laughing crying face emoji. So if you're looking for the number of characters each character set can represent, then ASCII is the worst. Extended ASCII gets better and Unicode is the best, but it's not all good because Unicode takes up more storage space per character than either of the other two. And that's all you need to know about characters.
Okay, so now you've heard a bit about characters and how it works. You're going to complete a Google Forms task whereby you will read an algorithm and answer some questions on it. So this is self-marking. This will be marked by Google Forms. You've got 10 minutes to complete it and review your answers. Off you go. Okay, so that's time up. Now, because that was a Google Forms exercise, you'll have got some feedback as you were completing that, or after you'd completed that. So we're going to move straight on now to the exam question on characters on ASCII Unicode. So for that, you're going to get 10 minutes, and then after that, we're going to hand to Mr. Barnes, who will review the task with you, and you'll make any changes to your answer. So you've got 10 minutes from now to complete the exam questions. Off you go. So now, as ever, we're going to go over to Mr. Barnes, who's going to explain the answers to those questions. Please make sure you correct any that you didn't get quite right.
Okay, so now you've learned about characters. Let's have a little look at these exam questions as part of our deliberate practice. Okay, so the first question is, explain how ASCII is used to represent text in a computer system. 3 marks. So we need to sort of try to make 3 points here, really. So I'm going to start with saying that each character is given a unique number. And this number is stored in binary. I'm going to go on to say that the binary number is 7 bits for ASCII, or a byte for extended ASCII. Okay. So, before we check that one, let's go on and do the next one as well. So, state what is meant by a character set of a computer. So, very simply, a character set is all of the letters, numbers, and symbols a computer can understand. Okay, so let's have a first look at these couple of questions and look at their answers. So, right, so we've got here, so explain how ASCII is used to represent text. So I've said each character is given a unique number, so each character is given a numeric code, so there's 1 mark. And this number is stored in binary, so the third bullet point here covers that as well. I've then said the binary number is 7 bits for ASCII, or 1 byte for extended ASCII, so each character takes 1 byte. Perfect. 3 marks. The next question then is, what is a character set? So I've said a character set is all of the numbers, letters and symbols a computer can understand. So it's got all of the characters which can be recognized or represented by the computer system. So perfect for 2 marks. Right, let's have a look at the last couple of questions then. So Unicode is also used to represent text in a computer system. Explain the difference between the character sets of ASCII and Unicode. Okay, so first of all, I'm going to say Unicode has more characters than ASCII. Okay, and I'm going to then explain why. Because ASCII uses a maximum of 8 bits, which is 256 characters. Unicode can use now up to 4 bytes, which is 32 bits. Okay. And then finally, in the ASCII character set, the character codes for the first 3 capital letters are given below. So we've got A, B and C and their representation. Very simply, we need to convert the word cab into binary using the ASCII character set. So I need to represent C first, which is 0, 1, 0, 0, 0, 0, 1, 1. Then A, which is 0, 1, 0, 0, 0, 0, 0, 1. And then B, which is 0, 1, 0, 0, 0, 0, 1, 0. Okay, so let's go through these final answers then. So, for the difference between Unicode and ASCII, we've got Unicode has a much larger character set, perfect, than ASCII, 1 mark. Because Unicode uses 16 bits, well, it's up to 32, and ASCII uses 7 or 8. Well, perfect. 2 marks. And then finally, for the cab question, and this is just a checker binary, so we've got 0, 1, 0, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 0, 0, 1, 0. Perfect. Full marks.
And that's everything you need to know for characters for your GCSE Computer Science. See you next time.